Hey guys, Dr. Brown here, and tonight we're looking at the 9 rules for Calc 1 differentiation. We had a video on this quite some time ago, but I thought, well, school started back. People are beginning to look into, you're in Calculus 1 looking at what are the rules, how do I survive this? And so we thought it would be a good time to go over the 9 things. If you can master these, hey, you're there, okay? You're going to survive and do well. All right, we have 9 of them laid out here. Don't pay any attention to what's on the other side. That's for Calculus 2 integration. I just left it up because I'll do another video tomorrow probably on that. Okay, we have 9 rules here. Let's just walk through them. A constant rule. When you're looking at the rate of change of a constant, it's sort of a, well, duh, it's constant. There is no rate of change. So the derivative of a constant is 0. So if your teacher says y equals 7, what is y prime? What's the derivative of 7? Well, that's 0. Rate of change of a constant is 0. It doesn't matter if it's 1, 10, 5 million, whatever. If it's a constant, the derivative is 0. All right, that's an easy one. The simple power rule. Let's say we have f of x equals x squared. Some function of x equals x to the second power. The simple power rule says I'm going to take that exponent and I'm going to bring it down. So I'm going to bring that exponent down here. So I have 2 times x. I had the square. I'm going to subtract 1 from it. So 2 minus 1 equals 1. So my f prime of x is 2x to the first power, or just 2x. That's the simple power rule. Let's try another one. Let's take x cubed. Let's say y equals x cubed. So what is the derivative of y with respect to x? There's a lot of different ways to write a derivative, okay? So again, the simple power rule says bring that exponent down and then subtract 1 from the power. So I would have 3x to the 3 minus 1 is 2. So the derivative of x cubed is 3x squared. The rate of change of x cubed, y equals x cubed, is 3x squared. That is the simple power rule. You'll use that over and over and over again. Now we'll expand that to the general power rule here just a little bit later. All right, constant multiple rule. It says if I'm trying to take the derivative of some function that has some constant times f of x, I can pull that constant out and take just the derivative of the function and have the constant times that derivative. Hey, all right, let's think about that. We have y equals 3x cubed, for example. And I want to take the derivative of that. So y prime, instead of me saying, well, the derivative of 3x cubed altogether, I can say, well, y prime is 3 times the derivative of the function x cubed. That looks bad, doesn't it? All right. Well, we just used a simple power rule saying that the derivative, I'm going to bring the power down, so it's, I'll put that in parentheses here, 3 times x to the 3 minus 1, which is 2. So 3x squared, that's the derivative of x cubed, 3x squared. But it's times the 3 I already had, this 3 that's out here. So now I have 9x squared would be the derivative of 3x cubed. So you can pull the constant out, and that helps simplify things to a degree. Okay? That is the constant multiple rule. sum difference rule. This basically is saying the derivative, if I have two functions, f of x, and you notice I put plus or minus here, but so let's say it's a sum rule for the moment. I'm just dealing with the plus sign. If I'm trying to take the derivative with respect to x of f of x plus g of x, the derivative of the sum is the same as the sum of the derivatives. Let's take 8x squared, something really simple. Let's let y equals 8x squared plus 2x squared. Your teacher will never give you the one this simple, okay? If I have 8 of something plus 2 of something, what does that mean? I have 10 of something. Okay, so that's 10x squared. Now if I take the derivative of 10x squared, y prime, I can use a constant multiple rule. Lots of things I can do here. 10 times the derivative with respect to x of x squared. So that's 10. And now we can use the simple power rule, 2 times the 1 that's in front of this, 2 times x to the 2 minus 1, which is 1. So x, so that's 20x. All right, so that would be the derivative of this function. So y prime equals 20x. Let's hold that thought for just a minute. Now the sum rule was saying that I can take the derivative of each one of these individually and add them together, and I should get 20x. So let's take the simple power rule. I'm going to leave the constant here. I'm going to 2 times 8, taking the derivative now. So y prime equals, I'm going to bring the 2 down, 2 times the 8 I already had, x to the 2 minus 1. So that's 16x. Now if I bring the 2 down here, I have 2 times 2, x to the 2 minus 1. So that's 4x. 16x plus 4x, hey, guess what? That's 20x. How about that? All right, so we can use the sum rule. What about the difference rule? Let's try the same thing. 8x squared, I have 8 of something minus 2 of something. Hey, guess what? I have 6 of something. 6x squared. Well, that's y. So y, I just simplified it. Now then, y prime, bring the 2 down. 2 times 6 is 12. X to the 2 minus 1, which is x to the first power. Okay. Now then, let's take these individually. We did this earlier. 2 times 8, 16. X to the 2 minus 1 is 1. So that's 16x minus 4x. 16x minus 4x is 12x. Okay, so the sum difference rule just says that I can, instead of taking the derivative of the sum or the difference, I can just take the sum of the derivatives or the difference of the derivatives. Get the same answer. Okay. All right, let's take sum difference here. A little bit more involved. Let's see. 3x squared minus x plus 1 all over x. Now we haven't learned the quotient rule. Simplify this. Since I only have one term in the denominator, I can just simplify this and say, well, that's 3x squared over x minus x over x plus 1 over x. Okay, now then I can simplify these. You remember the rule? If I have a to the m divided by a to the n, that's a to the m minus n. X squared minus x to the first, so that's 2 minus 1, which is 1. So it just gives me y equals 3x minus 1 plus x to the minus 1 to the negative first power. Now you might say, well, wait a minute, why is that? Well, this 1, in my mind, I think about that as x raised to the 0 power. Okay, x, any number to the 0 is 1. So I have x to the first power here. Remember what we just wrote, a to the m minus n? So now I have x to the 0 minus 1, so that's x to the negative first power. That's how I get that. All right, now then, we're ready to take the derivative of that. Since I have a sum difference rule, it's telling me I can take those individual derivatives, okay, and get the correct answer. So y prime, 1 times 3, so I'm bringing that 1 down to here. 1 times 3 is 3. X to the 1 minus 1, which is x to the 0. Derivative of a constant is 0. Now, this one, minus 1, bring the negative 1 down here. Negative 1 times x to the negative 1 minus 1. That's to the negative 2. Okay? So what do we have? X to the 0 power is 1. So I have 3 minus x to the negative second power, which is 3 minus 1 over x squared. That's how the sum difference rule will help you walk through a problem. Hopefully get the correct answer. All right. Number 5, the product rule. It says that the derivative of the product of two functions is the first function times the derivative of the second one plus the second function times the derivative of the first one. Okay, what example do I have here? X cubed plus 3, x squared plus 3, x squared, my eyes are not the best in the world, x squared plus 3 times x squared minus 4x. All right, we'll say that's y equals that. Y prime, the derivative, is the first function, x squared plus 3, times the derivative of the second one. Again, we're going to use now the simple power rule. Bring down the 2, x to the 2 minus 1, which will be x to the first power. Bring down the 1, 1 times the negative 4 is negative 4, x to the 1 minus 1 equals 0. So let's clean that up. X to the 0 is just 1, right? Plus the second function, g of x. I should have labeled these. This is what we're calling f of x, and this is what we're calling g of x. All right, plus x squared minus 4x times the derivative of the first one, 2x to the first power, just 2x. Okay, now we can FOIL this out. All right, let's see. We've got 2x cubed minus 4x squared plus 6x minus 12. That's this part. Plus, now if you had a negative here, you'd really need to be careful, okay, but I have a positive sign. 2x times x squared is 2x cubed minus 8x squared. All right, 2x cubed, that's 4x cubed minus 12x squared plus 6x minus 12. Now a person might say, hey, can I just do the sum difference rule and go ahead and FOIL this out and then take the derivative of each individual term? And the answer to that's yes. And you'll get the exact same answer. So, but if the teacher says, hey, use the product rule and you just FOIL it and take the sum difference rule, maybe they count off because you didn't work the right rule. I tell you what, let's see if we can do that here. All right, x squared times x squared is x to the fourth. That's this term. Minus 4x squared, 4x cubed, sorry. Minus 4x times x squared is minus 4x cubed plus 3x squared minus 12x. All right, so that's y equals that. Make sure we did this right. X to the fourth minus 4x cubed plus 3x squared minus 12x. Okay. Now then, y prime, bring down the 4, x to the 4 minus 1, which is 3, minus 12x squared, bring down the 3, x to the 3 minus 1, plus 2 times 3 is 6, x to the first power, and then minus 12. 4x cubed minus 12x squared plus 6x minus 12. So we could have gotten the same answer in multiple ways, okay? All right, that is the product rule. What about the quotient rule? It says if you have two functions, f of x divided by g of x, and you're trying to take the derivative of those, you have to take the function that's on the bottom times the derivative of the one on the top minus the function on the top times the derivative of the one on the bottom divided by the function on the bottom and in the denominator squared. Now I'll do something really simple first. Let's say I have y equal 8x squared divided by 2x. Now if we went ahead and divided that out, 8 divided by 2 is 4. X squared divided by x is x. Okay, if I took the derivative of that, 1 times 4 is 4. X to the 1 minus 1 is 0, so that's x to the 0, so it's just 4. So y prime equals 4. Now let's use the quotient rule. Okay, y prime, it said, and I would encourage you to take that function that's on the bottom, write it down, and square it. Do that first. That's my kryptonite with this method. I'll end up taking, just forgetting it and get obviously the totally wrong answer. Okay, the function that's in the bottom times the derivative of the one in the top. 2 times 8 is 16, x to the 2 minus 1, which is x to the first power, minus the function that's on the top. I'm going to put a bracket here, 8x squared times the derivative of the one that's on the bottom. So it's x to the first power, 1 times 2 is 2, x to the 1 minus 1, which is x to the 0 power, which is 1. 1 times 2 is 2. So what do we have here? Y prime equals 32x squared minus 16x squared all over 2x parentheses squared, which is 4x squared. 32x squared minus 16x squared is 16x squared divided by 4x squared is equal to 4. 16 divided by 4 is 4. X squared divided by x squared is 1. 1 times 4 is 4. Okay, that's what we wanted to end up with. Now that's a simple problem. All right, let's get something not too much more difficult, but a little bit. F of x equals x over x squared plus 1. Okay, F prime of x is, remember, x squared plus 1 squared. Don't forget that. Now, the bottom function, g of x, we've got what, f, well, I should have called this y, shouldn't I? Y equals this, because this top function is f of x and the bottom function we're calling g of x. All right, so we have the bottom function, g of x, x squared plus 1, times the derivative of the top function. Derivative of x is 1, minus the top function. I'm going to put a parentheses there so I don't lose any sign changes that may come up. First function times the derivative of the bottom. The derivative of x squared is bring the 2 down, 2 times x times 2 minus 1, so it's 2x. So that's 2x. Derivative of constant is 0, so 2x. All right, what do we have here? Y prime equals x squared plus 1 minus 2x squared all over x squared plus 1 squared. All right, y prime equals 1, so a minus 2x plus, and minus 2x squared plus x squared is minus x squared over x squared plus 1 squared. That is the derivative using the quotient rule. Okay, I would encourage you just write these down, keep them in your notebook somewhere. I guess everybody nowadays puts them on their phone, but I was old school. I just had a notebook full of formulas, full of everything you can imagine, and it served a good purpose for me. All right, chain rule and general power rule. These were some that, to me, they go together hand in hand. So let me take an example here. Y equals x squared plus 1 cubed. How do I take the derivative of that function? Now, the chain rule says if I'm trying to take the derivative of f of g of x. So there's an inside function and an outside function. Okay, so what's my inside function? Well, it's this x squared plus 1. What's my outside? Well, I'm cubing that. So I need to take the derivative of the outside function first. Well, I end up using it's the general power rule. And I guess I should talk about that before I go on. If you let u equal x squared plus 1. So if I did that, y equals u cubed. Wow, that seems pretty simple. Now I can just use a simple power rule here if I'm trying to take what is the derivative of u cubed. 3, bring down the 3, u to the 3 minus 1, and that's 3u squared. But u is a function of x also. And that's why, to do this properly, I now need to take the derivative of what's on the inside. This was my outside function. Now what's on the inside? Well, the derivative of u is 2x. Bring down the 2. So it's x squared, bring down the 2. X to the 2 minus 1, which is just 1, so it's 2x. So I would have 3u x squared plus 1 to the 3 minus 1, which is 2, times u prime, which is 2x. So this would equal 6x times x squared plus 1 squared. And that's how you can use the chain rule and the general power rule all in one time. And you will use this over and over and over and over. Okay, so really get familiar with utilizing that. Now, lastly, the derivative of trig functions. You need to commit these to memory and really get good using them. The derivative, for example, derivative of sine x is cosine x. Now you all have had trig by this point in time. You know that, let's say I have this 30 degrees, for example, so that's what, pi over 6. This is pi over 2, it's just 60 degrees, and that's a 90 degree angle. So what is that? 1 square root of 3, 2 would be, cosine of 30 degrees is square root of 3 over 2. So you're familiar with sine, sine of 30 degrees is the opposite over hypotenuse, so that's 1/2. So you should be familiar with sine, cosine, tangents, all of those from a trig perspective. Now then, we're looking at derivatives of those, rate of change. Now, and these are not so obvious. For example, derivative of cosine. Which rule can I use to come up with that the derivative of cosine is minus sine x? Well, I personally can't. So I have to remember what it is. Now you could say, well, the derivative of, with respect to x of cosine x, that's going to equal the limit as h approaches 0 of cosine x plus h minus cosine x all over h. Well, that's the limit as h approaches 0. If I take this cosine x, it's the sum of two angles. Well, there's an identity out there that says, well, that's cosine x times cosine h. Now, that's not hyperbolic. That's just that angle. Minus sine x sine h. Now that's all cosine x plus h minus this cosine x we already had all over h. If I were to collect the cosine x terms, bear with me as we walk through this, cosine x times cosine h minus 1. Okay, that if I distribute that cosine x, it takes out this one and that one, minus sine x sine h all over h. If I were to pull out the cosine x term and the sine x terms, because they're not a function of h, so I can move them outside the limit and have this situation. So this is cosine x times the limit is h approaches 0 of cosine h minus 1 over h minus sine x times the limit is h approaches 0 of sine h over h. Hey, all right, now then, as h approaches 0, cosine of 0 is 1. 1 minus 1 is 0. So I have cosine x times 0 minus sine x. And if you put your calculator on radians and you said h is approaching 0, so it's 1 times 10 to the minus 6, for example, you'll get 1 times 10 to the minus 6. Well, if h is 1 times 10 to the minus 6, 1 times 10 to the minus 6 divided by 1 times 10 to the minus 6 is 1. So that limit of sine h over h is 1. So this is 0 minus sine x times 1 is minus sine x. Okay, so the derivative of cosine x is minus sine x, and that's where it comes from. And it's the same, you can go through this same calculation for the rest of them, but you don't have time to do this on a test. Memorize them, okay? Because you're going to use these over and over and over and over. If you want to really get good at integration in Calculus 2, be really great in derivatives, because integration is just the opposite of differentiation. Okay? All right, well, that's all for now. Commit these to memory. Work as many problems as you can. Ping me if you need more examples, and we'll work through those. But commit these 9 rules to your memory and learn them very well. Why are we doing this? Hey, together we're trying to build a better tomorrow, and do that through math. So keep studying, guys, and we'll talk to you next time. Thanks.